Hello students, how are you all? So we are back with a new chapter that is light. Okay, so first of all, what we have to learn about the light? There are two type of light sources. One is luminous, another is non-luminous. How we can differ from it? Suppose in our home we use CFL, LED, tube lights, or also we have some candles. And as we know, this is the luminous light source cause it is making the light by itself. It is the original light source which emitting the light. Suppose you are reading some book in this light of candle. So what you have to do? The light from the candle is right now falling in your book. Then by reflection of those light it is coming in your eye. So as I told you, this is the luminous light source which making direct light from that object, and by reflection of light we are experiencing the image in our eyes. So where those who are produce the light itself, they are known as luminous light object, and those who don't produce the light by itself, that are known as non-luminous objects. So this is the very basic difference between them. Coming to the propagation of light, that how light propagate from one certain medium. As we know, we experience the propagation of light from air, but we know that in in water, in and in any other transparent medium also light can propagate. So whenever lights are propagating, we have to see from which medium it is propagating. Is that transparent material or translucent material? What do you mean by all those? Transparent material, that is material that allow the light to pass through them completely, and they are known as transparent materials. That means you can take the example as glass. So when the light passes from glass, there is no obstacle to block that light. The 100% light will passes from that. Maybe few percent will be reflected, but mostly the most of those light will pass from that. Coming to translucent, what is that? The material which allow light to pass through them partially. That means few amount of light will pass from that and few remain reflected or come back to its first medium. That means that kind of medium or that kind of material is known as translucent material. And finally, opaque material, that is nothing but which do not allow any kind of light to pass through. That is known as the opaque material. So these are very important with the proper definitions. Coming to the propagation of light with different ray diagram. So what do you mean by the propagation of light in the first? So whenever the light will fall, there will be light ray, and this linear line with this arrow is giving you the idea of a light ray, where this arrow denoting the direction of the light ray. Acha. So is there only one light ray? No. There are so many light rays which are together known as light beam. So as you can see, there are so many light rays. And one more thing, that all lines are parallel to each other. So this beam is known as parallel light beam. Now also there are two type of light beams which mostly come out from the source of light. Suppose you have a luminous light source, and from there the light beam will appear. But how? Suppose this is our light source, and from there in all direction the light beam will propagate. So this part is experiencing the divergent of light. As you can see, all the lights are moving, I mean all the light rays are moving further from each other. So that is nothing but the example of divergent beam. Now similarly, if all rays meet at a certain point, that means all the light's rays are getting focused. So it is the example of convergent light beam. So that is all about the light beams. Now coming to the rectilinear propagation of light. Whenever the light will propagate, it always follow a straight line. So I will dictate a small example over here, that is, by this experiment you can easily understand that light always propagate linearly. Suppose you can also find your experiment in your book, that is in this part. As you can see, I'm talking about this experiment. So we have three pieces of cardboard and linearly we have three holes. That means if you see from here, you can watch in the other side if any object is there. Okay. So as you can see, all the holes are linear. So whenever you light up some luminous object over here which will emit the light, you can see the light directly. But whenever if you displaced any of this cardboard from its original position or the initial position, you will find that this is now working as an obstacle. The light ray coming from the candle cannot pass through the cardboard because it's right now behaving as an opaque material. So that is why no further propagation of the light, and then we can say light always propagate by rectilinear position or in rectilinear way. So that is very important relation for the rectilinear propagation of light. Coming to the next part, that is the pinhole camera. You can also do the experiment in your home, that we are using one certain empty box over here, and in the one phase of this box we have the screen means any kind of white paper is there. So if any kind of image will appear, that will we can see from here. Okay, and also another small hole is given in this portion. So whenever some candle will be there, then we can easily see that by pinhole camera, the image appearing in this screen, it is completely inverted candle. But why and how it is happening? Because it is actually giving the light rays. So light rays are passing like this, and this light ray from the bottom is passing like this. So as you can see, A point, the light ray of A point is meeting at this, and the light ray of B point is meeting at this point. So you can easily watch over here that the image should be inverted. So that is what happening in this pinhole camera. If you notice one thing, if you move the candle further or closer to that object or the hole, you can see that the size of image are also changing. Why? Because due to moving this candle, I mean the object position, the image position varies also. So remember that. Coming to the shadow. Now what is shadow? We all know about shadow. If some object will block the light, then one dark shadow will appear with the same shape. So that is all happen due to the opaque material when it's blocked the light, but rest of the light which are not blocked right now, they can pass. So in this case we will have one dark shadow. Okay. Coming to the idea of shadow, we can see severally sometimes the shadows are too dark, sometimes they are lighter, or sometimes they are smaller. This all things is depends upon the position of the light source. If you move the light source towards the as you can see in one, it is also already given. A shadow is always dark area. It does not show the color of the object. These are the application of shadow that you have to read. Please mark it in your book. Okay, a shadow may or may not look like actual shape of that object. The size of shadows depend on the distance of the object from the source of light and the screen. So as you can see over here, if you take that light source in a proper distance, you will find a nearly exact shadow. But if you take the light too closer to that object, the shadow will be fade out. Finally, if you take the light far from that object, the shadow will get smaller. So this is how, by changing the position of light source, we can actually change the quality of shadow. Okay, so that is all about shadow. Also another thing is there, let me mention it. Coming to Umbra and Penumbra. What is that? Whenever we create the shadow, there are two regions. One is darker region, another is less darker region. So the central darker region is known as Umbra, where the outer less darker region is known as Penumbra. As you can see in this figure 6.19, that there are two parts of shadow for that wall. The central one is very dark, that is Umbra, and the outer one, that is little bit less dark or lighter, and that is known as Penumbra. Okay. So coming to the next one, that is the point source and the extent source of light. As I told you earlier, if you change the position of the light source, the shadow position or shadow size will also change. So this all are discussed over here with the position of source. What should be the position of shadow? As you can see over here in the first one, shadow formed when the source of light is smaller than the object. So when the source of light is smaller than the object, then the shadow will be bigger, as you can see according to the ray diagram. But what will happen if the light source is bigger than that object? It is form a smaller shadow that you can see over here, very small. So in this case, Umbra is big, but Penumbra is small. But in the left case or the last case, the Umbra is small and Penumbra is big. So also you can compare the Umbra and Penumbra with the size of the light source comparing to the size of the object. Now coming to eclipses. So there are two type of eclipses, we know that: solar eclipses and also lunar eclipses. So one by one we will discuss. First of all, what do you mean by the eclipse? For sun eclipse, we can see that the sun is blocked by something, or the sun is totally black. How does it happen? Suppose the sun is here, that is very large body. No one, even no other planet can block it. But moon is in a such position, that is, it always comes during the solar eclipse between sun and earth. So what happened? The light coming from the sun is actually totally blocked by the moon in a certain region of earth. And that is why, for that certain region of earth, no light from the sun will approach, and it's become solar eclipse for that certain region. So always remember that for the solar eclipse, we need the position sun, moon, then earth. Okay. All right. So, but for the other region, what will happen? The very close region to the main region will experience partial solar eclipse, because they will approach by partial light of sun. 50% light of sun will approach to that region, so they will experience partial solar eclipse with the same position. So that is all about the solar eclipse. Now coming to lunar eclipse. But in lunar eclipse there will be change of position of moon according to its rotation around the earth. Okay, so let me discuss it first. Similarly, in this case, we know that moon is a non-luminous object. It's only get light by the lights of sun. So what if the lights of sun will not approach to that moon? Then it will never be brighter. It will be completely dark, right? So who's blocking that the sun's rays to approach towards moon? The earth itself blocking the sun rays during lunar eclipse to approach towards moon. That is why all the sun rays are blocked by the earth, so no other sun ray is moving towards the moon. That means moon right now is completely black. So we can say that lunar eclipse is happening. That is called total lunar eclipse. But we know that moon changes its position. What if it's come out a little bit more by the rotation? Then we can see that there is a certain portion of moon which is mostly look like this is coming out. And that is what this portion of moon is actually the darker region, that is nothing but the shadow of earth by sun, and the brighter region that we can see from the earth is where the light of sun is approaching. So also in this case as well, we have total lunar eclipse and also partial lunar eclipse in the right section or left section. Okay, so that is all about the light. Still, if you have any doubt, you can ask me anytime. And in next class, we will start magnetism. Thank you.